209, is that right? 209. Yep, 37.8. And they want, what's the percent of men, what percent of men have a total cholesterol level less than 225 milligrams? Again, first thing I do on this, draw myself a little graph, 209's in the middle. And if you don't really need the graph, but it's just to visualize it a little better, you can like round this a little bit. Like I would maybe make it 38 so I can just add this a little bit easier. We're going 38 plus that is 247. 38 plus that is 285. 38 plus that is 223, I think. Subtract 38 from this, that's about 171. Subtract 38 from that, that's 133. Subtract 38 from that, that's about 90. 90, 38, 95. And they said, what percent of men have cholesterol levels less than 225? 225 would fall somewhere about in here. So we're looking at this percentage. First thing I notice is that my percent should be more than 50. If you're looking at that on your calculators, I think we can punch all this just directly into our calculator. We go on our calculators, we hit second bars, normal CDF. Let me make sure I read this right. What percent of men have total cholesterol less than? So we're looking at this part down here. Let's see, on this normal CDF we put in what all things do we put in again?
Put the 209, don't you?
209
Is
first?
it first? I don't know if it's first.
I don't remember. That's 209, then the mean, then the standard deviation?
Yeah.
So we want the 225 first, right?
Yeah, 225, and then.
So it goes your X score, your mean, then your standard deviation. Try it and see. Oops, hit the wrong thing. Second,
It gave me 0.
then that must not be the right way. Normal CDF. 225, comma, 209, comma, 37.8. Yeah, give me 0 too. What are we putting in wrong? Somebody help me out.
And the 37.8 first gives you 1. And 225, 209.
Somebody look it up on your notes. How do we put this in? What do we do? Oh, we gotta put it in 2 limits, don't we?
Oh, yeah, that's probably why.
That's what, my fault.
How do you,
I was thinking about what we're doing today. Today we're gonna put in 1 thing, or 3 things. So we're gonna put in this low limit, well, our low limit this time is like negative 10,000 maybe. Then we put in 225. Then we put in 209. And then 37.8. That's the way it should go in. So we hit second bars.
Yeah, you do the negative 10,000 first.
And you don't, again, you don't have to go negative 10,000. Nobody's gonna have a cholesterol level that you could go negative 100 or something. Just anything that makes sure we get everything on that left end. 225, 209, 37.8. and it comes out to about 0.6640, or about 66.4% if they wanted it as a percent. Part B says, there's 250 U.S. men, 35 to 44 age group are randomly selected. About how many would you expect to have a total cholesterol greater than 260? 260 is going to be somewhere about here. We're looking at what percent, or I'm sorry, how many men out of 250 would have cholesterol higher than that. So we'll punch in our low level this time is 260, high level 10,000, 209, 37.8. So second bars, normal CDF, 260, comma, 10,000, comma, 209, comma, 37.8, and it gives us about 0.0886. We don't want that number, that's the percent. They want out of 250, so we're just going to take 250 times that 0.0886. And you already got on your calculator, you can just hit times 250, and you get about 22. So about 22 out of the 250 would have cholesterol level higher than 260. Other questions?
You're at 10.
10? Problem 10. So they give us that. Let's see what they say do. Assume a member of this is selected at random from the population represented by the graph. Find the probability that the member selected at random is from the shaded area. Assume that the variable is normally distributed. So again, all they're wanting here is they're wanting what percentage is in there. That's the same as the probability. They tell us on this one, the mean is 197, standard deviation is 37.7. So again, if we wanted to put this into our calculator, if you wanted to do it that way, you could use the chart. If we wanted to change these into z-scores, if we just want to use the calculator, we hit second bars, go down to normal CDF. We want to put in the low limit. Put in the low limit, which is 190. Okay, didn't like that spot. High limit, which is 215. The mean, which is 197. Standard deviation, which is 37.7. So 190, comma, 215, comma, 197, comma, 37.7, and I come up with about 0.2571. So about 25%. Boy, that's. I wonder if we'll use, this is one of the few ones if we use the chart, it came out that, so it came out quite a bit higher if we use the chart rather than the calculator. Not sure why. Most of them come out fairly close. If you just looking at it, that one looks a little iffy, but, so we're saying about 25% or about a quarter of all the women that they talked to or did whatever with is in that area right there. Is between 190 and 215. Other questions? Gosh. Just handle it all, huh? All right, what we're going to be doing today, just going backwards. So instead of looking at the chart and saying, okay, what's the probability that somebody falls in this area here? Now we're going to be looking at this and we're going to be finding what values these two values are, given that this is like 73% of the area or something. So we're going to be finding those values. So still normal distributions. We're going to find the z-score given the area under the normal curve, transform that z-score to an x value. Again, we're probably going to let our calculators do a lot of that, but you've got to remember how to do the z-score to, and I put x value on here a lot of places. Remember the x value is the raw score. So transforming a z-score to a raw score or a raw score into a z-score. Find a specific data value of a normal distribution given a certain probability. This is probably, as far as you guys go, this is something that people are using on you right now if you're applying to colleges and stuff. You're applying to a certain college. That certain college has probably got some mark on this normal curve here. And that mark is maybe an ACT score or SAT score or a GPA or something. And they're saying, all right, we can only take a certain percentage of students because that's all we can handle. They want to know what that score, what that cutoff is going to be right there. So they use that to say, we're cutting it off at an ACT score of 20 or something.
Most colleges don't even take your ACT score.
They don't.
It's not a requirement. Unless you want to get like more money off your tuition.
That's good. I wish they'd get rid of it. All it is a way for the people who do that test to make money.
I don't think the test is how smart you are, it's how well you manage your time.
Yeah. Depend on which one you take, and the ACT is just make sure you answer everything that you possibly can, and the SAT is only answer the stuff that you absolutely know.
Yeah. Yeah, they literally tell you for the ACT, fill in everything.
Yeah.
Even if you don't know it. If I was going through it, filling in stuff, I have no idea.
We'll do this. There's going to be two different ways on the calculator, depending on if they want a z-score or they want the raw score. We'll do both ways. Sometimes they'll want the z-score as your answer. Sometimes they'll want the raw score. You just have to read the questions carefully to know which is which. The assignment today is sort of really long, but most of them we can do fairly quickly if we get to it. If we get to it pretty quickly. So, in the last section, we were given the normal distribution of some random variable, and we're asked to find the probability. Now we're going backwards of that. So if we were using the chart, if I have my chart here, thought I did. If we were using this chart, before we were looking out here and matching it up and coming down here and finding the area. Now they're going to give us the area, and we got to figure out what number that goes with. So we're using the chart, but using it backwards. Sort of like on your calculators, back in geometry class or in some of the other classes that use the trig functions. When you hit second sign, and it puts up that sign, -1, that's the inverse sign. So then, instead of finding the sine of the angle, you were actually finding the angle. You're working backwards. And that's the same thing here. This is when you were in geometry class and I gave you the chart with all the sine, cosine, and tangents on it. Same idea. Now they're telling you these numbers here, and you're figuring out what z-score matches up for that number. So, to find the z-score, given an area, determine the cumulative area to the left. Remember, everything on the chart goes to the left. Look up the area on the chart. Then you go back and just use that chart backwards and find the z-score. So you're just using the chart backwards. Using the chart's real easy, and we'll probably do an example here in a second. Using the chart's real easy if they just give you something to the left. So if they just give you some z-score, like right here, or some area right here, that's going out to the left, and you're trying to find that z-score, then we just look up that area on the chart and come up with the z-score. So using the chart's real easy. If we're trying to find something off to the right, using the chart is a little more difficult, just like it was the first section in this chapter, because the chart doesn't tell you the area off to the right. What you got to do is take this area and subtract it from 1 to find this area out here, and then look up that score, and that's going to tell you the z-score. It's not that much harder. You just 1 minus whatever the area is. But it's 2 steps then instead of just 1 step. So if we're finding the z-score that corresponds to cumulative area of this, if I go on my chart and I try to find 0.3632, first thing, remember the front page is negative z-scores. This page, the back of the front page is the positive z-scores. Well, if we're less than 50%, then we're going to be in the negative z-scores. If we're more than 50%, then we're going to be in the positive z-scores. So I'm just going to try to find 0.3632 on here. And I might be able to do it. 0.3632 is right there. So I look over here, and it says negative 0.3. And then I go up to here, and that says 0.05, so that means that next number is 5. That's our z-score. So in other words, if we're on our little chart here, that's 0, that's 1, 2, 3, -1, -2, -3. We're somewhere about right in there. So you just look that number up. The number isn't on the chart. If it's not exactly on the chart, then you just get as close as you possibly can. Figure out which one's the closest. So 3632 is right there on the chart. We look over here. Negative 0.3, we look up here. Second number is a 5, so it'd be negative 0.35 would be our z-score. If you're looking at something to the right, now this changed a little bit. It said 10.75%. To change that, that's a percentage. To change it to an area, we just bump that decimal over 2 places, so 0.1075. But now we're looking at, and this might be what a college does. If a college says, hey, we're only taking the top 10.75% of students, we don't want to let all the riffraff in, so they're only taking that top 10.75%. So that means that's the area out here. Zeros in the middle. The chart, again, only tells us the area this way. So the first thing we got to do is we got to take that number and subtract it from 1. And 1 minus that comes out to be 0.9725, I believe. That's not right. Is that 9? That'd be a 9. That's 2. That'd be a 9. That should be a 9 there. 9925. And if we look that up on the chart, well, if it's that number, it's going to be on the back of the first page. So if I go over here and I try to find 0.9925 or something close to it. It's right about there, 9925. This number out here is 2.4. Go up to 3. That's our z-score. So 2.43. Remember, if it's 2.43, we know that this is an unusual score. Unusual. Did it wrong. Should be an 8. Can't subtract. So that means my 2.43 is going to be wrong. Let's see what it does come out to be. So it's going to be 1.24. I could subtract, should grab my calculator. Find a z-score that's 96.16% of its area to the right. So same idea here. I'm not going to do this whole problem. But we want 96.16 of the distributed area to the right. So that means 0.9616 of the area over here. We're going to subtract that from 1. I'm not even going to try to subtract it again. That would be the number, whatever we get there. That's the number that we look up on the chart. That's going to be our z-score here. This one a little different. Watch closely on this one. A little tougher if you're using the chart. We want 95% of the area to be between two scores. So when that happens, what we're going to do, you're going to have two scores. You're going to have a score here, and we want 95% to be between them. We could figure this out using the empirical rule, because we said that 95% fell in between certain standard deviations out. That's what they're actually trying to show you here. But on the chart, so this is 0.95. how are we gonna figure out we're in between two things here? Because what we need for our chart is we need to know how much of the area is from here down. How could you figure out how much of the area is from there down?
Well, if that's 95%, the other two have to add up to 100.
So each of these has to be a total of what percentage?
100 or 1. So it'd be
So 5%
Five.
total, right? So how much is out here?
2.5.
2.5%, and then 2.5% on the other side. So if it's 2.5%, we bump that over. The area then is 0.025, and we can look that up on the chart. 0.025. 0.025, right there it is. And it looks like it says negative 1.96. If this z-score on this side is negative 1.96, guess what this one over here is?
1.96.
Positive 1.96. And it's always going to work out that way where your two z-scores are the same, just one of them's positive, one of them's negative, when you're looking at whatever's in the middle there. On your calculators, I'll give you a second to copy that down. This is if you know the z-scores. So if you're given the z-scores, or if you take all your roll information and change it into z-scores. Tried to find that picture in the yearbooks, but no.
Find it. I don't know if my dad still has his
I
middle
looked
school.
at-
What picture? That one. That's it? I thought he, yeah, he found it. Where'd you? Thought he was saying that find some picture.
I found a picture of George. And I was at my grandparents' one day, and it was like from the 70s, like my sister, my aunt's yearbook. He was like the guy walking with the coffee. He was like this tall, skinny.
Yeah, he was. Times change.
I looked at all the yearbooks, and our 8th grade yearbook didn't even have our 8th grade basketball team in it. Had the 7th grade basketball team real big on one whole page.
They just
No 8th grade
So
basketball.
that, then that's like the year. That off.
Screw you guys.
You guys, Michael, you have to make sure this year is red.
I parsed it. I did footwork.
So on your calculators, you hit second bars. You got to know when you're using this, when you're using the other stuff. It's sort of real close to each other, but second bars. Number 3 says INV norm. So that's saying the inverse norm. And what that's telling you is you're still using the normal distribution, but now we're using this chart. You're telling the calculator, use this chart, but use it backwards. Do the inverse. So we're finding the z-scores or the raw scores. For this, it's just the z-scores. And don't worry about this over here. That's for the other calculator. But we're finding the actual z-scores for this certain area. So again, where this is used a lot, some school or whatever, they only want to take the top 10%. Well, then what they're going to do is they're going to figure out what that z-score is, and then use that z-score to change to their raw score on whatever, however they're scoring those certain, that certain group of people, whatever they're looking for. Go second bar's inverse norm. Make sure you're getting the right thing. Punch in area. And that's all you have to punch in if you're dealing with z-scores, if you want a z-score. If you're finding the middle percentage, again, please make sure, draw a little picture. It doesn't have to be anything special. Just draw a little picture and say, okay, I'm finding, something in here. I'm finding something in the middle. On most of these, on all of these, I think, we'll actually be finding something like, that looks more like this, where we're finding exactly in the middle. So this z-score and this z-score are going to be the same, except one's going to be a positive and one's going to be a negative. And you guys did this right. We subtracted that percentage from 100, then divide by 2 to see how much is on each side. Look up the negative one on the chart, or use your calculator to find the negative one. And the positive one will be the same thing, just change the sign. This should say, this is about the fourth typo I found on this PowerPoint today.
How long ago did you make it?
I don't remember, a few years probably. I was reading through it earlier this morning and found 2 or 3 typos that I fixed. Didn't catch that?
Oh yeah, I saw that.
Yeah, right. He didn't have a clue, did he?
I would be dead.
He was looking around for a card. He was thinking, all right, where am I going to get this card at? Should have left it that way, because here in a couple,
I definitely would have put it to you.
here in a few days on the test, Michael being on,
Where's the
Where-
card?
where's the card at? What?
Where's the card supposed to go?
It says you can use the card.
I don't see one.
Braden would be thinking it, but he'd never ask. He'd just say, So again, if they give you, all you're gonna do with this, and again, we can use the calculator, but if they give you something like, you want 50% in the middle, then we want 50% in here, then that means on this side and this side, we want 25% each, or 0.25 of the area. And we look up that 0.25 on the chart, or use that on our calculator to find this z-score, which is going to be the negative one. Then the other one's just going to be the exact same thing, but positive. Percentiles, been a while since we talked about percentiles. Remember that P72 means the 72nd percentile. Somebody help me out, what's it mean to be in the 72nd percentile?
You
Need to have another vocab test.
72% higher than.
no, it's
Ranked.
no,
it's
it's
not
can't think of
I
it.
know you don't know.
It's literally like 10 bucks on.
2% of the average, whatever.
Close. You were higher than, or that score was higher than 72% of all the other scores.
These are worthless.
Anyways.
It's right here.
No, there's something.
Tells that 72% of the data is below that score, whatever it is. So if they say the 72nd percentile, you draw your little thing, you shade in the area down here, that area is gonna be 0.72. So if they gave you something like this, P20, we draw our little graph, that's horrible, but, and we want 0.20 of the area to be to the left. So you look at that number and that's telling you the area or the probability or the percentage. Find the z-score that corresponds to P5. So if we're in here, that's 1, 2, 3 again, -1, -2, -3. We could use our calculators. We could use the chart. 5 means we want to be at 5%. So that's going to be way down here somewhere, over here. And if we look it up on the chart, 0.05, got to make sure that you bump this over 2 places. So 0.05. If I look on my chart and find something that's close to 0.05, it falls right in between these two numbers. It falls right in between -2.58 and -2.57. If it falls right in between those two, what's the number actually going to be?
2.6, or no, hold on, 575, it could be any of those.
Wait, how would I thought it'd be 5?
Because it's right in between those two. So if I'm on the number line, and this is -2.57, this is -2.58, what's going to be exactly halfway in the middle here?
The 2.5 second.
We just want that with the 5 on the end, right? So that's what it should be at that. See if if we did it right. No, of course not. How'd I mess that up? Look at it wrong. Area is closest to 0.05. Oh, I looked at 0.005. You laughing about my, what's your fault?
How's it my fault?
So 0.05 is what they said, and that's same idea. You had to go halfway. Well, I'm having a rough day. So if we find the z-score for this, and I'm not going to find the z-score for each one of these, we'll use the calculator to find a couple of them. If it's this one, we want 50% of the area, or 0.50. If it's this one, 0.90. This one, 0.10. This one, 0.20. This one, 0.99. That's where Ebersole's score would fall at in relationship to everybody else.
For what?
For anything. So if we grab our calculator, if I want to do the first one, I hit second vars, go down to number 3, the inverse norm, hit enter, and just put in 0.50, close the parenthesis, and it tells me, and this one you shouldn't even have to punch into the calculator, what's going to have exactly 50% to the left. What's going to be right here where there's 50% over here? If we're on a standard normal.
I got a 0.
When it's 0, yeah.
It's always going to be the mean, which on the standard normal curve is 0. For this one, for 90%, so we're way over here somewhere, and we want 90% of the area to be on that side. We just hit second, vars, inverse norm, put in 0.90, close the parentheses, 1.2815. When you're doing z-scores, you want to go out 2 or 3 places. So 1.28 would be pretty good. How about this one? Just give me an idea on this one. Should it be a positive or a negative?
Positive, negative,
Which one? It's got to be one of them.
negative.
All right,
Why would it
zero.
be negative?
Zero's right in the middle, right? So if you want just 10% going out, we know from here over is what percentage?
Negative 50.
That's 50%. So anything under 50%'s got to be a
Negative.
negative. Anything above 50%'s got to be a positive. So this one we know is going to be a negative. How about this one? Negative.
Negative.
And
Positive.
that one's got to be a positive. Change your scores. Remember, your X is your raw score. Your Z-score is your standard score. This one we've written down a couple of times. This one here we may not have written down. I don't remember if we've written it down yet or not. But if you're changing something from a Z-score into a raw score, that's the formula.
Can I use the bathroom?
You think the Bengals would beat the Chiefs, Mr. Ebersole?
It's almost gonna get it this far with an offensive line.
Yeah. I'm saying beat the Niners.
So again, this first formula, find the Z-score. You take your score, whatever it is, it's your raw score minus the mean divided by standard deviation. We've done that one several times, did it last chapter also. If we want to go the other way, if we want to change from a Z-score to a raw score, then we're just going to punch in the mean there, the Z-score there, standard deviations there. You can punch all of that right into your calculator, and it's going to spit out whatever the raw score is for that certain setup, whatever setup you're dealing with. Veterinary records the weights of cats treated at a clinic. The weights are normally distributed with a mean of 9 pounds and a standard deviation of 2 pounds. Find the weights X corresponding to Z-score of 196, a Z-score of negative 0.44, and a Z-score of 0. Well, this one here should be pretty easy. If the cat's Z-score is 0, what's their weight going to be? What do we know that their weight's exactly the same as? The mean. Well, what was the mean? What was the mean this time? 9 pounds. So that cat we know weighs 9 pounds. The cat weighs 1.96 pounds. we want to change that into a raw score to find the cat's weight, then we just say our x equals, what was the formula again? So I don't have to go back.
What is it, x to z?
Yeah,
It's x minus the mu.
or no, z to x, I'm sorry.
Oh,
We're starting with z score.
mu plus z and then the standard.
Times the standard deviation, right? So the mu this time is 9, z score is 1.96, and the standard deviation is 2 pounds. You can punch all of that just that way into your calculator. What's that give you?
12.92.
So that cat weighs about 12.92 pounds. What's that tell us about that cat?
Well, it's over the mean.
It's probably overweight a little bit, right? Probably, the vet's probably gonna tell him, hey, you need to, cat's too big,
I used to have a cat like that.
needs to lose a little weight.
6 times.
Next one, the mean here again would be 9 plus, our z-score is negative 0.44 times 2, punch all that into your calculator. What's that give us?
Dude, I missed something.
What's that tell us about that cat?
It's underweight.
It's under.
It's under the mean a little bit. Does that mean that the vet's gonna say you're mistreating the cat? No, it's probably pretty close there, right? If we're looking at this, again, 0, 1, 2, 3, -1, -2, -3. What z-scores is the vet probably gonna say something to us and actually maybe be a little upset with us about?
Like
Two.
negative 1.5 and under and 1.5.
Probably two, -2 under.
-2 and under?
And then,
Because -2 tells us unusual, right? So there we're probably not feeding the cat enough, or the cat's not getting enough food somehow. If the cat's down here somewhere past -3, they may very well take the cat away from us. Same idea up here above 2. Above 2 is unusual, above 3 would be very unusual. Same idea on that. Remember, draw a little graph just to help yourself out sometimes, just to look at stuff.
That really does help me.
The standard scores, or the normal standard scores, 0 is always in the middle, that's the mean. If you're doing the raw scores, then the actual mean score goes in the middle. Same idea on this. So this is some California, so the police officer school's only taking the top 10%. If they're only taking the top 10%, then this part down here is 90%, so that means our area is 0.90 down there. If we want to find that z-score, we just punch that into our calculator. And we get a z-score of 1.28. I actually looked it up on the table for that, but. Then we could change that back into a test score. So the test score, if the mean was 50, the test score would be 62.8 or about 63. Using the calculator to find the x value. So now you're finding the raw score. If you want the raw score, which a lot of times is more useful. You want the raw score instead of the z-score. Again, we don't need this over here. This time you're going to punch in 3 things. Area, I'll write this out this way. Area, mean, standard deviation. Still going to go to that inverse norm. So now the calculator is not only using the chart backwards for you, but it's also transforming everything from z-scores into raw scores. Into an actual test score or an actual weight or whatever you're dealing with. Is Cody just not like my class?
No, he doesn't like Mr. Whittle's class.
Is that what it is?
Yeah.
And Mr. Wendell's class is on the same day?
It's first block.
You see what I did last year, just wait till I get the deal coming.
Late.
That's what I used, me and Kale Miller, we sat down on our car, we rolled there about 8:30, sat there for 20 minutes. In the ocean.
Basketball coach had a lot of problem with Logan.
A lot of problems with everybody.
He doesn't seem to,
It's weird. Like,
he just doesn't seem to care for Logan a whole lot.
it's like, at first it was me, and then it was Ethan, Murphy, and Wyatt, and now it's Logan.
He just seems to, he'll put Logan in for a minute and then he'll pull him right out. And I'm thinking, but he didn't do anything wrong. And when he pulls him out, he's always got to talk straight to him and stuff.
It's
I'm like, he didn't do anything.
terrible.
He didn't have any time to do it. And I can't say he didn't do anything. I know at least once, like,
Yeah, I mean, he does lead the team in turnovers.
at least once Logan was standing up there at the top, and I know that's not where he was supposed to be in the offense, and it looked like he was sort of doing it on purpose.
Well, sometimes he is supposed to be up
Well, I don't think he was supposed to be up
there.
there
That
then,
time, yeah.
because I think he was just standing up there because he thought, you know what, I'm gonna get pulled out anyway. Pass me the ball, because he's standing up there. And
He
Shot
made it. He made it.
shot a 3 real quick, and
And went in.
so again, if you're doing these, sketch the graph, find the z-score, maybe. Find the x value, depends on what you want. Be able to explain your results. So make sure that you can explain what this means, like with the cats and stuff. Hey, this cat was overweight, this cat was underweight. Be able to explain the results according to whatever it is that the problem's dealing with. The assignment, again, the assignment's pretty long, but most of them aren't very difficult. We got about 10 minutes if you wanted to do some of them, we can do them together real quick. That's up to you guys.
He won't be allowed.
Excited.
Yeah, I bet he is. I would be too. I missed 3 games. I mean, I missed it kind of, not gonna lie. But, like, when we put in Sonia, that's when they start hurting. It's like, oh, I gotta get back in.
You guys should be.
We should have beat a lot of teams. Should have beat Valley, we should have beat Sonia. Should have beat Eaton, should have beat Dixie.
What is his mom about?
You guys didn't even get there in time to watch my kid play.
No, we were running. We called in.
Yeah, I saw it.
Me and Kate were, they told us to get there. We waited an hour for them to school.
I
I was
see.
about to lose it.
I seen what you talked about when you started drilling up here. Yeah. He had 3.
Yeah.
That's not damn.
I saw that when you sent me a picture of the inside.
The hair kills me.
He should be shooting a whole lot more than he does. He's scared now to shoot.
Their head coach is
She's
sweet.
my sisters.
Something like that. Younger cat. He's pretty cool.
Just in his.
He
where's
wants,
his-
I've talked to him all, and I said, he's gotta shoot more. Said he won't shoot more, he's just chicken. You guys need to make him cry during practice. That's what I tell him.
And one play card shoots like.
The varsity.
Oh.
No. The
Oh,
Jimmy
but-
one. It's like the mohawk looking, weird looking haircut.
Yeah.
He shoots like.
And,
JT, JT pretty well.
he just came back. I don't think he played for about a month.
Same.
We were running late.
But then
That's what I told him. Hey, wait now, we're talking.
Leonard
Well,
was
we thought
getting
it'd
eaten
be
alive by
over,
that
but
one
then
kid.
for what? So Matthew and Kaya were repping the little kids.
33.
And,
Oh,
they went
Yeah, he
into
was
triple
just-
overtime. Tri Village.
he was just stronger than anybody you guys got on the team.
Yeah. I couldn't shoot to save my life.
I will say that my son played better that game. I told him after he played better that game than he has all year long, as far as doing the things that I want him to do. Being a little more physical, and still wasn't as physical as I'd like. Because there was a few of them times, when he's playing in the bottom of the zone and somebody cuts behind him, I want him to step back
And bump him.
and not just bump, because that's what he was doing, he was bumping. I want them to end up out of bounds.
I don't know what.
And make them go out of bounds and have to come back in. Because I don't know if it was against you guys or if it was against,
Just like pull it down.
if it was a game after that. So, one of the other kids got in, one of the kids that never plays, and the kid come across through there, I think it was against you guys.
In my.
And they knocked the kid out of bounds, and the wing passed the kid the ball while he's standing out of bounds. I said, that'll happen, because you get those guys in there that don't play a whole lot, and that wing catches the ball, and in practice, he catches the ball, and what's he do?
For it.
He throws the ball right there to that guy cutting down low. That's all he's thinking about. Hey, I'm gonna catch it. I'm gonna throw it to this guy. The guy's
See-
standing out of bounds.
You see that kid tackle me? He dove after the ball. It was out of bounds.
Probably. Oh, yeah.
I was
yeah.
like, I don't know why he did it.
I was waiting for Logan and the kid on Valley View is number 15. I was hoping,
Oh, yeah.
I was hoping that they would guard each other a bunch. Cause I thought,
Get into it?
oh yeah, there'd be a fist fight. Cause,
I wanna watch them, it'd be funny.
cause that kid on Valley View, he's a football player, he's not a basketball player. And
They're all football players.
that's all he,
He just wants to get physical.
yeah, and when Ferguson was out, that kid thought, oh, now I'm gonna shoot a whole bunch. And he was whining and crying and yelling, and, I mean, the official was pulling him off to the side about 4 or 5 times every game. Hey, it's enough.
Yeah, they're all football players.
Did you guys hear Wyatt on this game?
Yes, that was hilarious.
So our coach got teed up yesterday for, I don't even know what it was. He
Slapped the ground.
Slapped the ground and was like,
He said, I need a foul or
some kind of, just something little, and they teed him up. Whole crowd was going wild. And what was it?
Jim got quiet. Wyatt said, that's weak.
Yeah, and Jim got quiet, and said, that's weak. And I looked over to him and said, you wanna leave too? Wyatt got real quiet, and I was trying not to laugh, because Coach was looking right at us. It
I
was
was
so funny.
crying.
Speaking of fights during a basketball game, my dad told me a story. Rod got in the game finally.
Wyatt was trying to look around.
He got in. He
No,
punched
he
some
said
guy
Leonard-
from
he said Leonard
Demo.
what?
They just called him Demo. He was like, "Ow," and they were-
As soon as the guy looked over, literally went,
We had
Yeah,
Rod.
Rod.
I think Rod protected me one time. I went in for
he said he was gonna keep talking, but then he wouldn't be able to go to senior night.
I went in for a layup on a fast break and the kid tackled me from
Yeah.
behind. And Rod knocked him down or something. And Rod knocked
That's
him
what he
down.
did. He went,
You should know, you should like this.
So, the kid tackled me and he's on the ground, the kid gets up and shoves him back down or something.
That's about all Ron can probably do.
you wanna leave too?
I should be like, yes.
I can't say a whole lot, cause
He said, "I'll just stand for
they all
us."
made the basketball team, I got cut
Oh,
my
it's so
junior
funny,
year.
but it was just because I looked up at why I tried it.
But that was because, part of it was
I
because
cannot believe Leonard just,
the coach we had, I quit on
It
it
would
the
have been
sophomore
better if
year.
it wasn't like, if there was a student section.
Cause I was working and stuff and thought, man, I ain't got time for this. So I quit
I got a
basketball
T
in
for that.
junior year. He still wasn't too happy with me and he said, he goes, I won't keep you Ebersole, I'm gonna keep some sophomore that,
Probably didn't play very much.
yeah. I
Were
wouldn't
you
play the
on
whole
the baseball team there? Ron was telling a story about it. It was like their freshman year, somebody chucked the ball and they hit the coach in the head. He threw it from like the outfield, hit the JV coach in the head. Coach got knocked out.
What?
They were like, I guess Dad said they were like ridiculous, like the stuff they did before games. They get like drunk, they drank before games. And one of them chucked the ball from an outfield,
Whose
hit the
team?
kid in the head, hit the coach in the head, knocked him out.
What team, was that Cameron's basketball team, and the one kid got suspended because he had a 4 Loko in his
Yes.
water bottle during the game?
yes.
Yeah, and like in the Gatorade thing, he had a 4 Loko in it,
Yeah.
like playing,
No, Cam said he was on the bench.
been on the bench.
The guy was on the bench the whole game.
Cam got his first points.
Yeah.
Hey, you're just sitting on the sideline.
Like in the, like,
Is Cam
not his
JV?
little JV group or like actually on.
I can't remember, he said he was in like the A group, and then at the beginning of the season, he rolled his ankle, and
Yeah,
now
he got
he
hurt.
said he's back at the bottom, so he
He's still dressed.
He he goes with them, but he plays on like their,
He was in the JV team.
Yeah.
But he still like travels.
he travels
Yeah.
with the.
He said actually they're not that good.
They've been
He's
losing
in
a
their
lot.
Not very good.
They used to be good.
I told
Yeah,
Cam he should
Cam's
transfer back to IU East. They're actually pretty good at basketball. We
Cam's
went
the
there
big
and
rolls
watched the
around in the water.
Pippinger kid one night with
Cam's
the
the big
Williams.
rolls around the guy in the locker
He
room.
probably was like the sixth best player on that team, and he was a stud in high school.
They must all the must have good games. All the
Yeah, Sinclair and teams like that used to have that.
Sinclair got rid of their baseball too.
Well, I wanted to comment, that dude must have told him.
Yeah.
Screwed Peyton Lane
He was
over.
one of like the.
I know Sinclair basketball, when I
His game was like, I
left
was looking
the other
around,
school I
everybody
taught
was
at,
like,
they just
Gary
won the
lost.
state title.
They drink.
And like 3 or 4 of them went to Sinclair
Yes.
Like
to
that's
play
like.
basketball. They didn't even play. They sat the bench and they all got mad and quit.
Who?
2 years.
Bunch of Jefferson kids where I used to teach at.
They used to be awesome.
They used to be sweet. They had a,
My dad was,
actually,
my dad was talking about when they played, who they played Kaiser or something as like sophomore, freshman year. He said they all walk out there and it's like Rodney Dunn and a bunch of skinny white guys. And Kaiser's got a dude on their team whose legs are as big as tree trunks.
Yeah, it was,
He plays like professional football, I think, too.
he fired.
Yeah,
Chris said he-
my dad's like, you know, we're all a bunch of skinny white guys.
I just think in my
Whole
family,
team
just say
6'5".
one thing.
Fires was an all-state football player, all-state baseball player.
He's a stud at basketball. Have a good day, Mr.
You
Ebersole.
too.
I'll have to show my dad that picture now.
alright.